Alright, let's go over some of the key terms with our encapsulated instance variables here. We've declared a private instance variable. This has not been initialized yet. There's no equal sign, there's no value here. So it doesn't have an initial value. It's just been declared. So we can't start using this until we've initialized it. And we will initialize it in the constructor that I haven't built yet. That's when we build an instance of a shape, then the constructor will automatically run, typically initializing the instance variables. Then the instance variables, after being set up in the constructor, can only be accessed or changed through accessor and mutator methods. And that's the public method. And as we'll go through an example, and when we implement the shape parent in a circle child class, we'll see we'll access these public methods because the child won't be able to access its own private method because it'll be tucked away in the class, in the not just any class, but the abstract class shape. So you can see the constructor doesn't have any sort of return type because what it returns is a shape. So we already know that. Shape here is the method that we call when we are instantiating a new shape. And I'll give you an example of that in a moment. And we'll take a parameter when we which we'll set up as our initial value for the length. So I can I can mimic the mutator method, and so I can just have duplicate code here that says, okay, local length, you take the instance variable length and inject the local length into that variable, and that will copy that value over and give this its starting value. But another way to write this instead is to actually call this method called length and pass it this value as a parameter. So now when I create a shape, the parameter comes in, and then I'll call the mutator method and give again pass the parameter over here and call the same code. I wouldn't necessarily do that. I'm just illustrating the point. I think this is just fine for now. So imagine if I had a shape tester class with a main method. You can't do this because class is abstract, and I'll explain that in a moment. But you can see me calling this constructor right here. So the color coding, it helps a little bit. This is a class saying, hey, shape, I'd like to create a shape called X. In that spot, instantiate a new shape. So run the constructor and pass over the parameter it needs. And this is the float. So it'll activate this method and pass in the float, which will take this place for the length. And then a new shape will be created in memory. However, you can't do it like this. Because this is abstract, you can't create a pure shape. Just like you can't create a pure mammal, it always has to be some sort of an example of the mammal abstract class. Let's take a look at the circle example, and I'm extending or inheriting from shape, and because I am inheriting from an abstract class with an abstract method, I must implement that same method that's declared here, a return of float and no parameters on an area method. So I have to, overriding is not totally required, but best practice just to note that, hey, I'm overriding a parent method with this. And all I'm doing is returning the particular area formula for a circle. And the length I'm just assuming is the radius in this context, and because it's private here, I can't access it even from the child unless it was protected instead of private. But still, I can just use the accessor method, which is public. So I'll say whatever this circle's length is, access the public method, and then square it by multiplying it by itself and by a rough estimate of pi. Now this would not have a length, this whatever circle this particular example is, unless I run its constructor. Now I don't need to declare a constructor if this one is already set up. It'll automatically use this when I declare a circle. But let's say I wanted to do more than just set up the length. So I'll first need to do the parent's constructor. So I'll run super, and I'll pass over the length. And all that does is activates this method here, its parent, its supers, and it passes the length over and initializes the encapsulated instance variable. And so that's what is happening there. But what if I wanted to do more after that? Let's say I wanted to create a private float called, let's just say radius. Just a convenient way to write down half the length. And so now I can say, set the radius equal to length divided by 2. And so now I'll initialize the instance variable length, and then I will initialize a different instance variable called radius, and when that's half the length. So this is private, so I'll need to build the encapsulation methods, an accessor and mutator method as seen here. I'm not going to do that, but I'd have to do that in order to make the radius a little more functional. If I wanted to access it outside of this class, let's say in shape tester, I would need to build some way of getting this information. Or maybe I keep it private and it's only used internally, and if anyone else wants it, they can use the public length and divide that by 2. Whatever your app's needs are. So now let's revisit this. So let's just call this my circle, and I want to make a new circle with a diameter of 41.12 centimeters, or whatever measure of unit this is. Unit of measure, sorry, that this is. And so now I have a circle, and it's been it's running the circle constructor here, and I am instantiating it, and it will be instantiated in a heap memory. This variable will live in stack memory, and it will have a pointer over to the location in memory where circle exists, as well as all of its available methods, and all of that will be ready to be called in this allocated space in heap memory. So I'm creating that for my app here. And so now I could, let's say, system.out, print line, and I could print the circles, my circle, and I could print its area, for example. And this would return the area, and I would be able to print that. And it would calculate that, and it would let me access that. Or maybe I could, use its radius and or whatever. So that is the way we instantiate an example of a class that is inheriting from an abstract parent that also has declared an abstract method that needs to be implemented, preferably using the override decorator. That's what you call this thing that kind of decorates a normal method. And we also use a constructor in this class that uses super in order to first activate the parent's constructor and then allow us to do additional steps after that. So that's one of the reasons why you'd use super. Otherwise, no point in having a constructor to begin with, and it will just naturally use the super anyway. So no big deal. Otherwise, if you wanted to extend the constructor and do additional stuff, then we'll first call super and then continue on. And the last quick thing is just to review what polymorphic means, is that if I created an array list of the type shape, then I could have my shapes, and that could be a new array list. I don't need to typeset it again because it's already been typeset right here. And then I'll run a constructor on the array list to build that in memory. And now I could add in circles and other squares, anything that inherited the shape class. So I could fit many different types of shapes into this one collection, and I'm guaranteed that they will all have the area method, so I could loop through each one and print out all of their areas if I wanted to, or whatever I needed to do in this app, and whatever this problem I was solving by building all of this stuff. I could loop through all of my shapes and have it do any shapely thing. Cool. I hope that helps reviewing classes and polymorphism and inheritance. This is what it means to be an object-oriented programmer, because this is sort of the basic building blocks on how we solve problems using this approach in software design. We build objects like shapes and inherit them, and that's how we sort of organize our code into these objects. Cool. Let me know if you have any questions.